So let's take a look at section 4.7. I believe this is the last section. Yeah, last section until the chapter 4 exam. All right. So we're going to take a quick look again at solving quadratic equations using the quadratic formula. That should be capitalized. Then we'll do class activity number 2, graphing parabolas using the 5-step method. Because it's kind of odd graphing on the online My Math Lab, I'm going to go ahead and assign you guys a paper homework via La Lima. It might be 1 or 2 problems. I'll upload that to La Lima, and I'll also send you out a email link via La Lima, so you make sure you can get that. And then the last class activity will be quadratic equations, applications for those equations. All right, so let's go ahead and start class activity number 1. Let me just move my lamp here so you can actually see without too much of a shadow. All right, class activity number 1. Solving a quadratic equation. All right. Solving a quadratic equation. Okay, using the quadratic formula. Alrighty, and the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here is our problem, the one problem for this class activity. So we're going to solve the following quadratic equation. 2x squared minus 5x minus 3 equal to 0. Okay, so one thing, how do I know this is a quadratic equation? How do I know this is not a linear equation? Because remember, the methods we use to solve a linear equation are, different from the ones we would use to solve a quadratic. So what is the big hint that this is quadratic and not linear? Right here. It's actually a small thing. The square. That square tells me this is quadratic. That's the highest exponent we have going on here, x squared. It's a quadratic. All right, so in order to use the quadratic formula, we need to know our ABCs to plug it into this equation. So our A value, remember that is the item by the x squared, so that'd be 2. Our B value is going to be the number by x, the negative 5. Go ahead and find the C value. Yep, the C value is the number without a variable, negative 3. All right, so now we have our ABCs. We can go ahead and plug them into our formula to solve for x. So x is going to equal the opposite of my b, which is negative 5, plus or minus the square root of my b value, negative 5, squared minus 4 times a, 2, and c, negative 3. All over 2 times my a value, 2. All right, and remember, using parentheses is really good when we have negatives floating around. And 2 of our numbers here have a negative, so it's an even better idea to use parentheses when you're substituting in your values into the equation. All right, let's go ahead and simplify this. X equals opposite of negative 5 will be 5, plus or minus the square root of negative 5 squared is going to be positive 25. And then negative 4 times 2, that's going to be negative 8 times negative 3. 8 times 3 is 24. Negative times negative is positive. So plus 24. All over 4. All right, still simplifying here. 5 plus or minus the square root of, so 25 plus 24 is going to be 49. Ooh, that looks like a perfect square root number. All right, let's see, simplifying this. What is the square root of 49? I believe that is 7. So it's going to be x equals 5 plus or minus the square root of, I'd take that back, that's not going to be a square root. my handy dandy whiteout. All right. 5 plus or minus 7. So the square root of 49 is 7 divided by 4. Okay, so now we've got to the point where we have simplified everything we can. All we need to do is work on that plus or minus. Because remember, we're going to get 2 answers for our quadratic equations. So let's split this up to find our 2 answers. One option is 5 plus 7 divided by 4. The other option is 5 minus 7, because remember, we're looking for 2 answers. So 5 plus 7 is 12 divided by 4, which is going to be 3. 5 minus 7 is going to be negative 2 over 4, which will simplify into negative half. So our answers for x equals 3, and x equals negative half. Okay, and there we go. We went ahead and we solved this quadratic equation using the quadratic formula. And remember that in order to tell, or when we're looking at an equation, the good hint that it's quadratic is looking at that square value right there. And sorry if you can hear the dogs barking in the background. This is why Manalo. Okay, so that's it for class activity number 1. Let's go ahead and look at class activity number 2. Okay, so let's see. Class activity number 2. Here we go. Graphing parabolas using the 5-step method. All right, so graphing parabolas. In this class, we have learned so far to graph just one other kind of equation. Let me pull out my sticky notes here. So we have our linear equations. Let's say, for example, 2x plus y equals 5. That was linear. And remember, we could tell it was linear because the x just has a power of 1 by it. And when we graph lines, basically, a line, remember, is always going to be straight. And we went over how to graph those lines before. Now we are looking at quadratics. And quadratics graph something different than a line. So if for a quadratic, let's say 1x squared plus 3x plus 2 equals y. Remember, we can tell it's quadratic because we have the square. So quadratics will graph things called parabolas. Okay, that's that word right there. A quadratic equation, when we have that square, if we graph it, it'll end up looking something like maybe that, or maybe that. They might be a tighter shape, or they might be a wider shape, depending. Okay, so each quadratic equation will graph a different type of parabola, just like each linear equation will give me a different type of line. So we're going to go and look at how to graph a quadratic equation. And to keep things relatively straightforward, we have a 5-step method, so we don't forget when we're graphing anything. And I'll go ahead and we'll introduce the steps as we go. All right, so the first step, step number 1. The first thing you do when you're a kid is you learn the ABCs. So that's what we're going to do. List, let me actually write this in a different color. I'll choose blue. All right, list the ABCs. Okay, the first thing you do as a kid is you learn your ABCs. Same thing for this. So first we need an actual problem to be graphing. So I'm going to go ahead and we're going to use the equation. Let me write it in. Now I'll just highlight it. So graph. Y equals x squared minus x minus 6. So that is the equation we're going to graph. Let me let it dry for a second, then I'll highlight it. All right, so we're being asked to graph this quadratic. How do I know it's quadratic? I got that square going on by the x, so it's not linear. All right, so listing our ABCs, let's see. Our A value is going to be what's by the x squared. What's by that? It's a positive 1. Remember that invisible 1? A is 1, B is going to be negative 1, and C is going to be negative 6. All right, so in the ABCs, there are a few important things to note. Our A value and our C value have special features for our parabola. Because remember, our parabola is this weird U-shaped thing going up or down, right? So what our A value tells us, it tells us whether our parabola is going to be opening up or down. And I have to figure out which one it is. So the way I think about it is a smiley face or a sad face. This is a happy face, right? And this is a sad face. So what I do is if our number is positive, we have a happy face. But if our number is a negative, like a negative 1, we're a sad face. So an opening down parabola. But our number is positive. So our parabola is a happy parabola. He's opening upward. Okay, the B value we don't use for this step. The C value. Now the C value tells me my y-intercept. Remember, if we're looking on an axis, let me draw it in real quick. If we're looking at the x and y, wherever our graph crosses the y value, that's our y-intercept. So this is our y-intercept. So I'm going to go ahead and label it our y-intercept. Remember, we want it as a coordinate point. 0, negative 6. Okay, so that is step 1. You list the ABCs, you indicate if your parabola is opening up or down, and then you list your y-intercept. Step 2. Our vertex. Okay, so I'm going to be explaining what the vertex is. Let me grab a sticky note. Alright, so if I'm looking at parabolas, they definitely look different than lines. So here's 2 different parabolas for us. One opening up, and one opening down. And there's this special point for each of them, which is sort of, I guess, where the middle is. If you were to just draw a line smack down the middle, that would be the special point. Okay, so both of them have these 2 points. These are called the vertex of our parabola. So this is this one's vertex. I label it with a V, and here's the other vertex. All right, there's also something very important about the vertex, okay? That's where we use the words maximum and minimum. Those come in helpful when we're looking at apps or applications, word problems. So this point here, the special thing about this point for this graph is that, notice, it is the smallest possible point. It's the lowest point. All other points on this graph are higher than this point. So this point for my graph is called the minimum. So if your graph or your parabola opens upwards, if it's a happy graph, it has a minimum, a smallest point possible. Okay. Now, for this type of a graph, if it's opening downwards, does this have a minimum? Well, if you said, yeah, this point right here is the minimum, I could just say, well, remember, the graph extends. That's not the minimum. And then you could say this is. But then I could say, well, it extends further. So actually, if it opens down, it does not have a minimum. What it has instead is a maximum. A highest possible point. This point right here, he's the highest point. He's on the top of the mountain, king of the hill. Okay, it's the highest possible point. So parabola opening downwards will have a maximum. And a parabola opening upwards will have a minimum. Okay, and those points, those important points, are called the vertex. And for the vertex, there is a formula for how we find the vertex for the x value. Okay, so we're looking for a coordinate point here. All right, so I'm going to indicate it. Remember, I said V for vertex. My x value, V sub x. And how we find this is we use the formula negative b over 2a. And when I say b and a, I'm referring to those points I pulled off up there. So this is an important formula. Always works when we're finding the x value for a vertex. Let's go ahead and plug those in. So minus my b value, -1, all over 2 times my a value, 1. That is going to be 1 over 2. Now, to find the y value of our vertex, there is no standard formula for everything. This is a standard formula that works. My y value, however, is based on my given problem. Okay, so based on the given problem, v sub y is based on the given problem. And this one, v sub x, is standard for all. Okay. So what I'm going to go ahead is, see this equation right here? Wherever I see x, I'm going to substitute a half into it. So we're going to use x squared minus x minus 6. I pulled that from up here. And we're going to plug in a half for x. And let's go ahead and simplify that. That'll be a fourth minus a half minus 6. And I can go ahead and make them all have the same denominator. So remember, using the building up technique. 1/4 minus 2/4 minus 24/4. And what's that going to be? It's going to be, oh, what is that? My brain's going off. Okay, -1 minus 2, so -25/4. And if I wanted to have that as an approximate, let me pull out my calculator. Around 6.25, a negative. Okay, and I can plug that in, -25/4. That's my vertex. So we're going to go ahead and pause and start actually graphing. Now, graphing is step 5, but it's important to work on it as we go along. So let me go ahead and set up some of my tick marks here. Sadly, this won't be accurate because I didn't bring any graph paper with me. And I neglected to print some out. Okay. So, my y-intercept was 0, -6. 1, 2, 3, 4, 5, 6. My y-intercept, 0, -6. And let's see, what other point did I find? My vertex, right here. So my vertex is going to be the point half, and it's around, if you look at my example, -6.25. So it's a little smaller than here. So that is actually where my vertex is going to be, v. And I'm going to label my y-intercept. All right. So one thing to note, for my parabola, I want to have 5 points. Need 5 points. At the moment, I have 2. So we're going to go ahead and figure out how to find the other 3 points. Let's take a look at step number 3. Step number 3 is called x-intercepts. Okay, you have to be careful here because we will not always have x-intercepts for parabolas. You might be asking, well, why? I'll show you some examples with my handy-dandy sticky notes. All right, so if I have a parabola, 2 examples here. I have a parabola, and I know that it has a vertex here, and that it opens upwards. Will this graph have x-intercepts? Well, a refresher on an x-intercept. An x-intercept is when my graph passes the x-axis. Will this graph opening upwards ever pass my x-axis? No. So this has no x-intercepts. Another example of a parabola that wouldn't have x-intercepts is maybe my vertex was below the x-axis and it opened downward. Will this one ever cross upwards here? No, it won't. So this one will also have no x-intercepts. So I need to check. My vertex is down here, and which way does my parabola open? Well, it opens upwards, which means, will it cross the x-axis? Yes, it will. So I can go ahead and find x-intercepts. Because if you happen to have one of these cases and you tried to find x-intercepts, you'd end up with a really strange looking problem. You start to get things called imaginary numbers. Okay, so we know we have x-intercepts because the vertex is down here and my parabola opens upwards. So how do we find x-intercepts? Remember, we set y to 0. And where is y? Well, it's with my original problem, right up here. So we'll use our equation, y equals x squared minus x minus 6, and set y to 0. Now, what does this look like? That looks like a quadratic equation, which means we need to use the, yep, you have it right, quadratic formula. So x equals negative b, my b value I already pulled off right here, negative 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times my a value, 1, c, my b value, my c value, negative 6, all over 2 times a, which is 1. Remember, I pulled those off of there. So simplifying this, it's going to be 1 plus or minus the square root of 1 plus 24 all over 2, which will equal 1 plus or minus 1 plus 24 is 25 all over 2. Simplifying square root of 25 is going to be 5, and we get 1 plus 5 over 2 and 1 minus 5 over 2, which will simplify into 6 over 2, which equals 3. And that is negative 4 over 2, which simplifies into negative 2. So we have 2 answers, x equals 3 and x equals negative 2, which means we have 2 x-intercepts, which makes sense because remember, a parabola looks sort of like a little U shape. Here's pulling off my example. Parabola looks like a U shape. So if we're crossing the x-axis, there's going to be 2 x-intercepts. So the fact that we have 2 answers is not surprising. And let's go ahead and write them as a coordinate point, 3, 0, and we have the other one, negative 2, negative 2, 0. Now let's go ahead and plot those points. 3, 1, 2, 3, 0. And the other point, negative 2, 0. All right, now all we are missing is one other point. I have 1, 2, 3, 4 points. So I'm going to go ahead and use, there are 2 methods we can use. Let me pull this to the side so we can use the other method. So here we go, step number 4 is finding the other points. Okay, so if we're missing our 5th point, so this is if missing points. Remember, need 5. Okay, so we have 2 options. The first option is we could just pick a point. Let's say I pick, so I'll pick an x value, let's say 1. What would the matching y value? Well, to find that, I'll just use my equation. You know, like how we do functions. Finding that, so y is going to equal, well, we said let's choose x to be 1. Remember, you could pick any random point. I would choose a small point because if you picked the point like 100, for instance, I have not made enough tick marks to pick the point 100. The only tick marks I've used are 1, 2, 3, 4, 5, 6, 7, 8. So a good idea would be to pick an x value smaller than 8. Okay, so we just picked 1 because it's a nice small number, easy to graph. So that's going to be 1 minus 6, which will equal negative 6. So this would be the point 1, negative 6. 1, negative 6. Right there. Hey, that's a nice point. So that was option number 1. We pick a point, plug it in, solve for the other point, and we get our coordinate set. Option number 2 is something actually a little simpler. It's called the line of symmetry. Okay, because what you might notice about parabolas is they look rather symmetric, as in if I took this piece of paper, let me do it this way. If I took this piece of paper and I folded it along the vertex, this point here, I wonder if I can do that.